Okay, so I'm testing the infrared sensor's ability to see through the ball. In the previous video we looked at the ultrasound sensor, which proved that it cannot see through the ball at all. So same setup, we have a wall, we have our IR sensor. The sketch is super simple. It's just reading the voltage from the input, from the analog input. So we can see right now we're running at around 180 for how far the wall is away. If I put my hand in front of the sensor, we see it spikes up to 500, 600, high five, something like that. So it is working. When I put the ball in front of it, so this one's the opaque ball, we can see that we get some of the infrared's able to come through, but not all of it. So where my hand was jumping it up to around 600, this stays around 480, and certainly the further away the ball gets, the better the reading becomes. So not really exactly what I was expecting. I did expect the opaque ball to certainly impede the infrared sensor's ability to make readings through it. I didn't think it would affect it quite that much. So, and the same as the ultrasound, it doesn't seem like a viable solution for navigation from inside of the ball. So I would think that this still is a decent solution for cliff detection, though. If the sensor remains closer to the inside of the ball and is facing down, we see that we do get at least an indication that there may be something there. It's not as strong as we would want it to be, but it could work out in that sense. So at this point, both the ultrasound and the infrared are not really viable options as internal sensors. So that means for my design, the sensors need to sit external to the ball. Whether that is through mounting them on the head or through a central axis, yet to be determined. So either way, good test, good to figure this out now. I'll move on.